GMAT all day.
For our last quadratic equations video, let's look at another way they like to vary difference of squares within more complicated equations and expressions. So this question here says if 81x to the fourth minus 16y to the fourth all over 3x minus 2y is equal to 45x squared plus 20y squared, and 9x minus 2y is equal to 31, what is the value of x? So let's start by rewriting our equations. Let's start with the easy one first. Do not forget that you have this information. 9x minus 2y is equal to 31, because it looks like the majority of our time is going to be spent with this guy here. You don't want to forget that you have this guy here. So this says 81 x to the fourth minus 16y to the fourth all over 3x minus 2y is equal to 45 x squared plus 20y squared. Now, for these questions, that happens sometimes in these video series, I sort of spoil the key to the question just based on whatever the name of the chapter or the video is. And so on your actual GMAT, it's not going to say difference of squares in the top right of your screen whenever you're given a difference of squares question. And so if you're sort of on alert looking for difference of squares, well, let's think how I would probably actually approach a problem like this when I saw it. I have this complicated equation here, and so I always try to start with easy things first. And so I'm not necessarily focused on this guy here. The thing I see that stands out is I can factor out a 5 from my right side. Now, one thing I definitely don't want to do is I don't want to try looking for a difference of squares on my right side here because I have a plus sign here. So I'm not thinking, I don't want to be tricked into thinking I have a difference of squares here when I don't. I don't want to be making up difference of squares where they don't exist. So I will just factor out a 5 here. That gives me 5 times 9x squared plus 4y squared. That is all equal to 81 x to the fourth minus 16 y to the fourth all over 3x minus 2y. So far, I think nothing really cancels out or anything. So the question then sort of becomes, is there such a thing as a difference of fourths? Because that looks to be what we have here. And I don't think I've ever heard anybody use that term, but I also don't think that anybody really needs to use that term, because anytime that you have an even power, you can express it as a square. So x to the fourth is really just x squared, and x to the sixth is really just x cubed squared, and x to the eighth is really just x to the fourth squared, etc., etc., etc. So if we're trying to extract a difference of squares from here, it would be in this format, a squared minus b squared, which means our a squared would be equal to 81x to the fourth, and therefore our a is the square root of this, which would be 9x squared. Our b squared is 16y to the fourth, therefore our b is the square root of this, which is just 4y squared. So if we wanted to rewrite this in its factored form, we would have 9x squared plus 4y squared times 9x squared minus 4y squared all over 3x minus 2y. This is equal to 5 times 9x squared plus 4y squared. This has me happy because I can divide each side by 9x squared plus 4y squared. Those guys cancel out. But now I'm left with this 9x squared minus 4y squared over 3x minus 2y is equal to 5. Doesn't look like there's really anything I can do here. If we try bringing down our second equation now, so 9x minus 2y is equal to 31. And we use this. And even though it sort of looks like we can, I don't think there's much we can do with it at this point. So visually, I think they're trying to trick you a bit by making you think that maybe the numerator here is related here because you got this 9x squared minus 4y squared and then 9x minus 2y. Maybe you're thinking, can I take the square root of this because I got this 9x and I get the 3x over here? But really, There really isn't much you can do. And so this is the important thing about recognizing when you have difference of squares with powers greater than 2. Oftentimes, when you have that, you can do difference of squares twice. So look at what we have here. We have 9x squared minus 4y squared, which is a perfectly nice looking difference of squares again. And so this is usually going to be the easier difference of squares to recognize. So don't pat yourself on the back when you factor it for the first time necessarily, but then miss when you have a second difference of squares. And so if I were to put this difference of squares in its factor form now, it would be 3x plus 2y times 3x minus 2y all over 3x minus 2y is equal to 5. Now I still have this guy here as well. So now these 3x minus 2y's cancel out, and I just have two easy-looking algebra expressions. 3x plus 2y is equal to 5. 9x minus 2y is equal to 31. They're asking for x, and just like before, our two equations line up very nicely. If I just add them, my y goes away, which is what I want. So 12x is equal to 36. X is equal to 3. And E is the answer. So that is difference of squares, or that is our quadratics chapter, I should say. Know how to factor them, know how to distribute them, know how to recognize quadratic equations, know your special quadratics, have them memorized backwards and forwards, and then know how to recognize difference of squares.